So we'll be seeing here in this slide, we'll be seeing how to add a node in beginning. This is I'm actually not very good spelling with spelling. So beginning of the linked list, how to add a node in the end of the linked list, and how to add a node in the middle of the linked list. Okay, and all these operations now which we'll be seeing in case of a doubly linked list. Okay, so let us suppose we are having this linked list. This is a doubly linked list. Okay, and the data which is stored here is A, B, C and D, correct? And let us suppose the addresses are 1000, 2000, 3000 and 4000. Here this node is pointing to this second node, therefore it is pointing to this node, it is pointing to this node, it is pointing to this node, and it is pointing to this node, it is pointing to this node, it is pointing to this node, and this last node is pointing to the front node. And this this is actually just a doubly linked list, it is not doubly circular, right? Therefore last node will not point anywhere, so the last node will be null here, and the initial node will also be storing null here. Okay, so let us suppose we are having this linked list. Now in this linked list, head will point to the initial node, therefore head will be storing 1000. Right, now let us write a function to add a node in the beginning of the linked list, and then this function is going to return the address of the head. Okay, so we are going to do add begin function. Okay, and then it is going to take node star head, that means the address of the initial node of the linked list, and int or whatever the data type is. If the data type is character, then it will take character data, so it is character info. Okay, and for this we can even write a create node function, or we can just create a node within this function. Okay, so what we are going to do is we are going to create a node within this function, because we haven't written a create node function for this doubly linked list. Okay, so let us write a function, let us write how to create this node with this data. Okay, so what we'll be having this is we'll be creating one more node which is node star new node, that means that there's a new node. Okay, and then new node is equal to node star malloc size of node. Okay, this is how you can create a node. Okay, and in this newly created node, in the data part, we are going to store this information. So node new node arrow data is going to store information, and initially both its pointer will be null. So new node arrow previous is equal to null, and new node. So it is not necessary actually to make this data as previous. We can exactly start with allocating the addresses, but here just to make you understand, so that we can create this, how we can create a new node in the case of doubly linked list. I'm writing this. So new node's arrow next is equal to null. Okay, so what happened in this few lines of code? In this few lines of code, we have allocated some memory. So let us suppose this is the allocated memory, right? And in this allocated memory, we have stored the information here in this information part. So let us suppose the information which the user passed is E. That means we have stored E here, and we made this part as null, and we made this part as null. Okay, that means this is the previous part, this is the next part, and this is this. Okay, and the new node pointer is pointing to this. So new node is pointing to this node, and let us suppose the address of this node is 5000. Okay, so this much we have done in these 4 lines of code. Now we want to add this node in the beginning of this linked list. right? Then how will you add this node in this beginning of the linked list? To add this node, you have to store the address of this 1000 node here. That means you have to store the address of this initial node here. So it should point to this position. This will be the first operation, and then you have to store the address of this node to this position. That means it should point to this node, and then you have to make head point to this node, right? That means there will be 3 operations. So first operation will be in this position you have to store the address of this node. Okay, so how will you do it? You just have to do no new node arrow next is equal to head. Okay, that means at this position you have stored the address of the head. So this position is now storing 1000. Okay, and then you have to make this node to point to this previous node, right? And the address of the previous, this node is pointed by head is pointed to that node, right? So what you have to do is head arrow previous is equal to new node. Okay, that means here at this part we just stored the address of this previous node. Okay, so let me just come back here, and that means here at this part, so it is actually not very good. So okay, so here at this part we have stored the address of the previous node. That means we'll be storing 5000 here at this position. Okay, now these 2 nodes are pointing to each other, and now we just have to change head. That means head should point to the new node. So head should point, instead of pointing to this position, now head should point to this position. Okay, so for that we have to do head is equal to, so it is not arrow, it is equal to, so head is equal to new node. Okay, and then we just return the address of the head. So return head, and this is how you can add a node in the beginning of this linked list. So it will be node star. Okay, now remember, in all these cases whenever we are adding a node or deleting a node, we have never checked whether the linked list is empty or not, because I wanted to make things as simple as possible. Now we can write this same function, but for this same function we have, for every function we have to check whether the linked list is empty or not. So how will you write the same function with checking that linked list is empty or not? You just have to write node star add begin. Okay, and then node star head comma character information. Okay, then you can perform all these 4 operations, these 4 operations here. That means you have with including this operation here, that means you have included that you have created a new node. Now you have to check whether there is a linked list present or not. So you have to see if head is equal to null initially. That means if there is no linked list present, then just store the address of this newly created node into head. That means you have just added a node in the linked list, right? And that node will always be in the front of the linked list. Then you have to do head is equal to, so head single equal to new node. Okay, and then if and else if the node is this initial node is not empty, then you have to use this complete data here, right? So else if the linked list is not empty, then you can add a node in the front of the linked list, right? This is how you can check whether the linked list is empty or not. Okay, so now let us see how to add a node in the end of this linked list. Now assume that we are having this linked list and we want to add a node in the end, right? That means at this position after this node. So that means we have to reach to the end, and here in this function initially we are going to assume that linked list is empty. So if the linked list is empty, and then we can easily add a node at the end of the linked list, because whatever the node which we will be adding is always within the one single node which is present in the linked list, and that one single node will be in the beginning, plus that one single node will be the end. Okay, so what we want to do is we want to add a node in the end of the linked list. Okay, and here I am assuming that we have written a create node function. okay, because we have to repeat that 4-5 lines of code again and again. So instead of repeating that 4-5 lines of code, it is better that you create one single create node function, and whenever you need to create a node, then you just use those 4-5 lines of code. Okay, so let us suppose we are having this function. So with this function is add to the end of the linked list, and this function is taking argument as the head of this linked list. So node star head comma character information, that's whatever the data you want to add. And for this every node these are the parts. One is the previous part, second one is the data part, and third one is the next part for every node. Okay, and then we are going to create new pointer node star p is equal to create node information. That means you have created some head create node function. This create node function is going to create a node, and it is going to return the address of that node into this p okay, this p pointer. And then you are having this above linked list, and you have to identify whether this linked list is empty or not, because if this linked list is empty, then you can easily add a node in the beginning. But if the linked list is not empty, then you have to go till the end of this linked list. Okay, so what you can do is, if head is equal to null, that means there is no node present in this above linked list, then you can just do, then you can do head is equal to p. That means you just added a node into the linked list. Okay, but what if the head is not null? What if the head is not null? So else what you are going to do is, and in the above position also, actually you have to return the address. So it will be a return head. Okay, and here the return type will be node star. Okay, else if the linked list is not empty, then you have to reach to the end of the linked list. Okay, so then it will be while, you can just take one more pointer, which is node star q is equal to head. Okay, that means q and head both are pointing to the same position. So while q of next is not equal to null, you can do q is equal to q next. Okay, and after this you have to do q arrow next is equal to p, and p arrow previous is equal to q. Okay, and then in the end we will be returning return head. Okay, so this will be our operations. So let us see what we have done in this function. So in this linked list we have created a new node which is p. So let us suppose this is a newly created node which is pointed by p, and when this it was a newly created node, and both these parts are null, then means this is the previous part, this is the data part, and this is the next part. Both previous and the next part is null, and it is storing some data. So let us suppose the data which it stored is e, and this node is pointed by the pointer p, right? And then here I have taken one more pointer q which is pointing to the initial node, so q is also pointing to this node. Okay, and then we have taken if head is equal to null, that means if the linked list is null, then you can just easily add this node in the head. That means you have one single node in the linked list, and then you can easily return the address of the head. But if the linked list is not null, in that case we have to execute this else condition, right? In this else, the statements within this else braces. Okay, and then we are doing while q of next is not equal to null, that means while this part for q is not equal to null, right? Then we just have to move the q to the end, right? So if this part is not null, right, it's not null, therefore q will now point to this position. Then again we are going to check this part is not null, then q will point to this position. Again we are going to check q, this part is not null, then q will point to this position, and in this position this part is complete part is null, right? Therefore q will not move to any other position, right? So this is how you can make a pointer q to reach to the end of the linked list. So after this, the Q will be pointing to the last node of the linked list, and the last node of the linked list, you are having this next part and the previous part. Right? Now how will you add a node to the end of the linked list? To add this node, you have to store the address of this node into this position. That means you have to make the last node point to this position, and you have to make this node point to the last node. Okay, so what you have done is Q of next is equal to P. That means here into this next part, you have stored the address of the newly created node, and then P is previous is equal to Q. That means in the previous part of the P, you have stored the address of the previous node, right? That means you have just added a node in the end of the linked list. Okay, and then you can return the address of that newly added node. Correct? So this is how you can add a node in the end of this given linked list. Now you can easily write a function to add a node in the middle of the linked list. To add a node in the middle, you just have to identify how will you reach to the middle of the linked list. Okay, so you can use the above previous functions which you have already written. In this, for the case of single linked list, one function was reach to the middle, right, and using the pointer, and another one was using the count node function. So what we are going to use is, we are going to use that reach middle function using the pointers, and that reach middle function is going to return us the address of the middle node. So here in this case, the address of the middle node will be this 2000. So after reaching to this position, let us suppose we want to add this node into the middle of this above linked list. Okay, so to add this node in this position, you have to store the address of this previous node, and in this position you have to store the address of this node. Okay, and then in this position you have to store the address of this node, and in this position you have to store the address of this node. So these are the 4 operations which you need to perform to add this node in the middle of the linked list. Okay, so we'll be writing a function to add a node in the middle. So it will be node star. The return type will be node star, because we are going to return the address of the beginning of the linked list, and then we are doing node, we have to write the function name actually. So it should be add middle. Okay, and it will be node star head, comma, character information. That means what is the data which you want to perform, which we want to add, right? And then we are going to take node star P is equal to create node with this information. Okay, so we are going to call a create node function, right? And then we are going to take one more pointer, which is node star Q. Okay, and this node star Q is going to store the address of this middle node. So how will you reach to the middle node? You can just call the reach node function. So we can just call reach middle node function. Okay, reach middle, and you pass the address of the head here. Okay, so with the help of that reach middle function, you can easily reach to this position. That means Q will be pointing to this position. So after reaching to this position, your work is very simple. You have to perform these 4 tasks. Okay, so let me just write this. This is the next part. For every node, this is the next part, and this is the previous part. Okay, here also this is the next part, this is the next part, and this is the previous part. Okay, so initially what the first work which we have to do is, in this newly created node, and this newly created node is pointed by P. In this newly created node, we have to add the address of the above nodes. Okay, so what we are going to do is P arrow previous is equal to Q. That means you have just added the address of this node into this previous position, and then you have to do P arrow next is equal to Q arrow next. Right, that means you have added whatever the data present at this location into this next part of this P. Okay, that means you have added the address of this is node 3000 into this P. Okay, now it is your turn to change the original nodes. Okay, and from these original nodes, we are going to change this data first, and then we are going to change this data. Okay, so what we are going to do is, we can take one more pointer here, or we can just do Q arrow next arrow previous. So what I'm going to do is Q arrow next arrow previous. Okay, so what does it mean? It means that if Q is pointing to this node, from this node I'm going to access the next part, and this next part is pointing to the this node which has 3000. Okay, and from in this address 3000, in this previous position I want to store some address, and in this position what I am going to store is equal to address of P. That means this position now is pointing to P, and then we have to do Q arrow next is equal to P. Okay, and these are the 4 operations which you need to perform, and after these 4 operations you can just return the address of head. So return head. So this is how you can add a node in the middle of a doubly linked list. Okay, so this is a very simple thing. Don't be very confused if you cannot understand how I have done all these things. Try to write a function by yourself. Okay, and if you can write a function by yourself, then it is very good, right? And if you cannot, just rewind the video, try to watch it again, and if you are still facing the problem, then do let me know. I'll make one more video. Now let us see how to add a node in a circular linked list. Okay, so let us suppose we are having the circular linked list. See, every operation is the same actually. So I do not have to teach you from the beginning, because if you understand one single linked list, then you can do all these operations in other linked list also. Okay, so instead of writing the program here, I'll be telling you what are the things which you need to perform. Okay, because in that way you can write your function by your own, and as if you do practice, because this solving the gate questions is actually based on practices. So if you practice a lot, then you can easily solve the questions. Okay, so let us suppose this is the circular linked list which we have, and this is pointing to the head, and the data which is stored into the circular linked list is A, B, C, and D. Correct? And this position is storing 2000, this position is storing 3000, this position is storing 4000, and this position is storing 1000. Okay, now first function is add a node in beginning. Okay, and then you will be adding a node in the end. Okay, and then you will be adding a node in the middle of the linked list. Okay, now if you want to add a node in the middle of the linked list, then what are the operations which you need to perform? So let us suppose this is the newly created node. Okay, and this node is pointing by P, so initially this part will be null, and it is storing some data E. So now if you want to add this node in the middle of the beginning of the linked list, then what you have to do is you have to store the address of this node, okay, to this position. Correct? And then you have to store this the address of this node 1000 to this position. That means you have to make this node to point to this position, and you have to make this point to this position, and then you have to make head point to this node. So that means there will be 3 operations, and in every case you have to reach to the end. Okay, then how will you add a node to the end of the linked list? So you have to reach to the end, and obviously you have to store the address of the head of the linked list, right? And how to add a node in the middle of the linked list, which you can already do. So if you face any problem with this a linked list, circular linked list, about how to add a node in all these different positions, then do let me know. I'll write one more video for this. Okay.